In this video, we're going to be introducing what a differential equation is. So a differential equation, or DE for short, is an equation. It's an equation involving an unknown function, unknown function, and some of its derivatives. I forgot how to spell derivatives. That's embarrassing. Okay, so that if that doesn't make sense, just hear me out for a second. So back in grade school, you were probably introduced to Newton's second law. All right. And what Newton's second law stated was force, and this is how they showed it to you, right? Force equals mass times acceleration. And they would give you some like unknowns, and then you would basically solve for the known variable, right? So they'd give you acceleration and force, and then you'd solve for mass or something like that. But if you take a minute to appreciate what this formula actually is, it's basically a differential equation. And if you will think about this for a second, the given force is dependent on position x. So we can write F as f of x, and then we can write mass, but then acceleration we can write also in terms of x. So x is just a position, right? X is just a position. So if x is a position and you take a change in x with respect to change in time, and then you take a very small change. You take a very small change in x, so dx and dt, then that is equivalent to velocity, right? And then that's velocity. But then if you have this thing, right? If we have velocity, and then we take velocity with respect to time, that gives us acceleration. So we can write acceleration as here, let me be more clear. So d dt. So we're going to take the derivative with respect to time of velocity, and then that will yield d2x dt squared. So then this is a representation of the position x, with where this is acceleration, right? So and let me add one more thing. So we know that x is position, but the position is actually going to be dependent upon time, right? So we can write xt like this, and so the unknown function is xt. It's not fx, it's xt, and that seems a bit confusing, but the unknown function is xt. But anyways, that's not important. So we can write f of x as d2x and dt squared. So then that is your Newton's second law written in a more mathematical term. And now notice, if we were to write this in a more, I guess, ergonomic way, then we could write this as x double prime, right, with respect to t. And so, yeah, or actually, yeah, we could write it like with respect to t. That's fine. And so this is what it comes down to. And so now, as you can see, we've got this equation in a mathematical sense, and f of x is a second order differential equation. And so, speaking of order, let's talk about order for a second. Let me get a new color. What color should we get? Let's get green. Okay, so now we have green. And all right, so let's talk about order. All right, and so not law and order, just order. And so order of differential equation, right? So the order of a differential equation is just the highest derivative of the unknown function. So the unknown function was x, right? So and we know it's x double prime, so therefore it's a second order differential equation. So this is highest derivative of unknown function. Okay, and yeah, so that's just order. It's a good thing to know because this is going to come up a lot, right? They're going to be like the first order, second order. We're going to be going over first order and second order in very thorough detail in the first few videos of this course. So yeah, and now that we've covered the definition of order, we also need to go over two more definitions. So this is not going to be important right now, but later on in the course, you'll see the importance of this. So there's an ordinary differential equation, and there's what's called a partial differential equation. Okay? Ordinary DE, partial DE. Okay? So, let's see. So an ordinary differential equation is just a differential equation whose unknown function depends only on one variable. So basically, here I should write this, the unknown function, and I should put a line here, unknown function, oops, only dependent on one variable, okay? I.e. fx equals mx double prime t. All right, so there where the x is dependent on time, the position is dependent on time. And then for partial differential equations, the unknown function depends on more than one variable. On more than one variable. Okay, so we'll go into this later. You don't need to know this now, but basically, we're gonna have to deal with heat equations and wave equations in like the last part of this course. And then you're gonna get this monstrosity where U is the heat equation and it's dependent on position and time. And so this will be like some wacky, gross function that we have to deal with. Yeah, that's about it for this video. So all it was that I was trying to show you that you need to know, key points are what a differential equation is. All it is it's an equation where you have an unknown function and some of its derivatives. So you can have, we're gonna go right away into first order differential equations, and we're only really going to have an unknown function where it's going to be just this plus xt, and so plus something, right? And this could be a constant, so let's make that 3, I don't know. And so you would have to solve this, and I'll show you how to solve this. But basically that's new. The idea is that you have an unknown function x and you have some of its derivatives, right? So you not only have x to the t, you also have x prime to the t. So then you have more than one of the same like representation of the function, but they're they're the same base function, but they have been modified, in this case by a derivative, right? So yeah, I hope this was a concise and thorough introduction to differential equations. I hope that helped answer some of your questions. See you in the next video.